For slide 6, it says, as you read, write down important information in the 3 boxes. I've put an example on the next page. So when I finish with this video, you can go to slide 7 to see an example. But first, we're going to go to STEMscopedia, and we're going to read the text. As we read, we are going to write down the important information about physical properties, chemical properties, and facts that we find. Reflect. How can you describe a piece of paper? You can talk about its color and size. What other properties of paper can you identify? Properties means physical and chemical characteristics of matter used to describe or identify a substance. Imagine that you took a full sheet of paper and folded it into a paper airplane. Would you still have paper? Yes. Being flexible or foldable is a property of paper. Will paper burn if it is near a flame? Yes. Being flammable is another property of paper. You could measure other properties of the paper, such as its mass, its volume, and density. Properties help distinguish one substance from another. Here, distinguish means to be able to tell apart. Not all properties can be seen when you first observe or measure a substance. Physical properties can be seen without chemically changing the matter, while chemical properties are observed during a chemical reaction. Physical properties are characteristics that can be observed or measured without changing the substance, such as state of matter, solid, liquid, gas, color, melting point, boiling point, odor, density, and conductivity. This would be a really awesome thing to jot down under physical property. Chemical properties are characteristics that can be only observed or measured when atoms of matter rearrange during a chemical change, such as flammability, burning, corrosion and rusting or oxidation, reactivity with the oxygen in the air, and reactivity with water. Some metals explode in contact with water. This would be an awesome idea to jot down under chemical property. Look out! Some physical properties depend on the size of a substance. An intensive property is a bulk property and does not depend on the amount of matter. Intensive properties include shape, state of matter, color, temperature, density, sink or float, hardness, resistance to breaking, luster, shine, texture, malleability, which is the ability to flan, ductivity, which is the ability to be drawn into a wire, flexibility, the ability to bend, attraction or repulsion to magnets, melting point, boiling point, odor and heat conductivity, electrical conductivity, solubility or the ability to dissolve in water, and viscosity, the resistance to flow. For example, when a diamond is cut, the pieces maintain their intrinsic property of hardness. A piece of paper remains white even when folded. Water will freeze at 0 degrees Celsius regardless of the amount of water present. Intensive properties can be observed and measured to determine the identity of a substance. In contrast, an extensive property is proportional to the amount of material. Examples of extensive properties include mass, length, and volume. A ream of paper has more mass and volume than a sheet of paper. A foot-long hot dog has more length than a regular hot dog. What do you think? How can you measure physical properties accurately? Use the proper equipment to measure extensive physical properties of mass, length, or volume. Finding mass. Use a balance scale to measure the amount of mass in an object in grams. Be sure to set the mass sliders to 0 if using a triple arm balance. Look at the scale numbers at eye level. Move the 100-gram slider to the right until the balance arrow is centered. Then move the 100-gram slider to the right until the arrow is centered. Lastly, use the 1 gram slider until the balance arrow centers. Only the 1 gram slider can be placed in between two numbers. Add the 3 measurements for the total mass in grams. So you would add the 300, the 50, and the 4.6 to get 354.6 grams. Note, when finding the mass of a liquid, there is one extra step. You must subtract the mass of the empty container and subtract it to get the mass of the liquid alone. Finding length. Using a metric ruler or meter stick to accurately measure the length of an object. Remember, a meter stick is usually 100 centimeters long. Each centimeter is divided into 10 millimeters. Note, do not confuse the inch side of the centimeter with the centimeter side of the ruler. So we have a centimeter side and an inch side. Finding volume. For solids with flat sides, use a metric ruler to measure the length, width, and height in centimeters. Then use the same formula you would in math class. To find the volume of a rectangular prism, for example, use V, or volume, equals length times width times height. Your answer will be in centimeters cubed, or ml. Conveniently, 1 centimeter cubed has the exact same volume as 1 ml, so these units are interchangeable. To find the volume of an irregular solid, place enough water to submerge the object in a granulated cylinder. Write down the volume of the water. Carefully lower the object into the water. Record the volume of the water and object. Then simply subtract the volume of the object in milliliters or centimeters cubed. This is called the water displacement method for finding volume. So for example, 100 minus 80 equals 20. So the object would be 20 milliliters. We're going to skip the chart for now. We'll do that tomorrow as a class. Then we're going to look at the chemical properties. Consider the following objects and describe some of their chemical properties after observing a chemical reaction. We're going to work on this table together. Reflect. Properties and reaction. The production of a new substance is the only undeniable evidence that a chemical reaction has occurred. By examining the physical properties of the substance before and after the suspected chemical change, we can determine if a new substance was produced. For example, sodium is a shiny silver solid, and chlorine is a toxic green gas. When sodium and chlorine react, they form sodium chloride, or table salt. Sodium chloride is a white granule solid. We know a chemical reaction has occurred because the properties of salt are so different from the properties of sodium and chlorine that it is easy to observe that a new substance was formed. Look out! It is not always easy to determine if a new substance was formed. Sometimes the products of a chemical reaction can share some properties in common with the reactants that form them. In these cases, very careful observation and measurement of many different properties should be made to determine if a new substance has formed. For example, when hydrogen peroxide, H2O2, is left out in an open dish, it will go through a decomposition reaction, breaking down into water, H2O, and oxygen gas. This reaction of peroxide in the dilute solutions we can buy at the pharmacies will be very slow and impossible to observe simply by watching the liquid. However, if these properties of the clear liquids are carefully observed before and after the reaction, it is possible to prove a chemical change occurred. The table below shows one physical property and two chemical properties that could be used to prove a new substance was produced. So we can see odor, pH, and the reactivity would be all ways we could determine if a chemical reaction occurred. Remember, your job is to fill in some important information about physical properties chemical properties, and facts. When you finish, you can look at my example on slide 7.